Organic acids are organic compounds that contain carbon, hydrogen, and oxygen. When we look at organic acids, they again have a functional group that identifies them as being different from other types of organic compounds. In this case, we're going to have a hydrocarbon chain of some length. On the last carbon on that chain, what we're going to notice is that we've got that hydroxyl group, which we had before, and we've got that double bonded oxygen. So that COOH is what identifies an organic compound as an acid. When we go to name it, we'll count how many carbons there are, and that'll be our prefix, and our suffix will be oic acid. So let's say we've got this as an example. When we see that COOH at the end of the hydrocarbon chain, that tells us it's an organic acid. And we'll draw it as its structural formula. So we've got CH3, CH2, CH2, and then we've got that COOH. And again, this is the functional group that makes this an organic acid. When we go to name it, we need to figure out what our prefix is, and our prefix has to do with how many carbons. So 1, 2, 3, 4. So that's our butane. So we've got butanoic acid. Okay, again, the oic is the suffix that we use when we look at organic acids. So if we go the other way, where we're given the name and we have to write the formula, this tells us that it's an organic acid. So we know that COOH is going to be on the end of the hydrocarbon chain. And the pent tells us we've got 5 carbons in the chain. So 1, 2, 3, 4, 5. That would be pentane. And to make it an organic acid, we'll put that oxygen and that OH. And then we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 additional hydrogens. This carbon already has 1, 2, 3, 4 bonds, so it wouldn't have a hydrogen coming off of it. Now we saw a relationship between alcohols and ethers and aldehydes and ketones. There's a very similar relationship between acids and esters. So when we look at acids, we know that we've got a hydrocarbon chain, and on the last carbon, we've got that COOH functional group. For esters, we're going to get rid of this hydrogen and replace it with another hydrocarbon chain. So when we name them, what we're going to need to do is recognize where the original acid was and where the new replacement for this hydrogen is. The replacement for the hydrogen is going to be this beginning of the name, and the acid is going to be the number of hydrocarbons, and we're going to replace the oic acid with O8. So let's look at an example. We're going to draw the structural formula again. So we'll start from the beginning. We've got CH3, CH2, CH2, and then we've got these O's here, which are going to be attached to this C. So COO, and then we've got CH3. So when we look at this, we're going to have this part of the compound was our original acid, and the hydrogen was replaced with this carbon here. So this would be methyl. And then this would be 1, 2, 3, 4. The prefix for 4 is but. So butanoate. So methyl butanoate. So if we look at another one here, we're going to actually do the back end first. So this was the original acid. 5 carbons, so 1, 2, 3, 4, 5. And we've got that COO. We're going to replace the hydrogen with an ethyl group, which is 2 carbons. And then we'll fill in our hydrogens.